at
Check this out, you guys.
0% belief in the moon landings in 1969.
This will not go well, especially because we can prove the moon landing happened pretty easily using publicly available information. Let's look at the 1972 Apollo 16 moon landing, which Candace also thinks didn't happen. The reason we're looking at this one is because they shot some incredibly useful footage that is publicly available to watch. The footage is of the so-called Lunar Grand Prix. In this clip, you'll see rooster tails, dust kicked up by the wheels following a really nice parabolic arc, and it's these rooster tails that provide the evidence that we need. See, you can track the motion of the dust in the rooster tails by looking at how the peak of the tails move relative to the back wheels. So let's first look at the vertical motion of the rooster tail. Using frame-by-frame footage, we can calculate the vertical speed and acceleration of the dust. What we find is a nice parabolic motion, exactly as if something was falling under the influence of gravity. However, and this is critical, the rate at which the rooster tail falls is slower than we would expect on Earth. On Earth, one would expect the rooster tail to experience 1 g of acceleration downward. However, from the data collected, it actually experiences 1/6 of a g downward. Strange, but let's keep going.
Okay.
Next, let's look at the horizontal motion. This is measured by horizontal distance to the wheel. Again, using frame-by-frame footage, we can plot the horizontal motion. Here we see something critical. The speed of the dust in the horizontal direction doesn't change. But if you've ever thrown dust or flour or whatever, it always slows down and then drops to the ground vertically rather than just continuing at speed. In that case, it slows down because of the air resistance. And that means that the dust in this footage is not encountering air resistance. That is, it's in a vacuum. So from this video, we can establish that the dust is falling with 1/6 of Earth's gravity in a vacuum environment. That's not reproducible on Earth. We can't make vacuum chambers that big, and we definitely can't control gravity. So what's the other option? Oh, the moon. Conveniently, the moon doesn't have an atmosphere, and its gravity is 1/6 that of Earth's. Now, the most obvious objection is that it was shrunk down and filmed in a smaller vacuum chamber. The trouble is, this would make the gravity appear even stronger than the Earth's. For example, if you shrunk it by a factor of 6, then the gravity would appear 6 times larger than the Earth's, or 36 times larger than we see in the footage. So shrinking it down would also mean that you have to slow down the footage, in this case by another factor of 6. And so maybe you say, okay, except it's not okay. Because it's smaller by a factor of 6, the grip strength of the tires also goes down by a factor of 6. And the acceleration stays the same, because the shrinking factor is the same as the slowing factor. And that means that the buggy would have spun out rather than accelerating from rest easily like we saw in the video. Of course, some people will just say that it's CGI, but to them I ask, have you seen CGI from the early 70s?
That's
How would they
crazy.
accurately reproduce this effect?